All right, thanks for the intro. This talk is labeled as fun and people on the program. We'll see about that. Just briefly the logistics. My name is Jonas. I work at a company called Symergen. I hope you all went to Amelia's talk earlier. She's my colleague and she explained to you what Symergen does. I'm on the automation team there. I write software for robots. Those slides are going to be super full, some of them, and that's because I want them to be also useful as reference material. This is the URL where you can find them. If that's too much to type, just go to my Twitter, and the pinned tweet is also a link. That should be helpful to follow along or to check it out later. What's in this talk? 4 sections. The first one, if you've been at that holiday party, you've already seen. I'm doing the lightning talk. Again, it's a quick demo, barcodes from first principles. If this is the second time you see it, good news is it's a lightning talk. Take a quick nap. I'll wake you up for section 2. Section 2 is barcode theory. So just a little bit of like the basics of how do barcodes actually work, all the terminology and stuff we need to talk about using barcodes in Python. And then finally, I hope I have enough time for that left. I want to show you some tricks and some sort of like almost like hacks of how to use barcodes in the real world and also how not to use barcodes in the real world. But let's start with this first section, which is that lightning talk that was mentioned in the intro. Oh, no, not that one, that one. Basically, I started this out last time by saying, oh, I use Python to write software for machines that interact with the real world. And obviously, when you do that, you very quickly realize that your software is stuck in the server. It's like in this box, and it can't really reason about objects and locations in the real world. And that's not a new problem. Engineers have had that for a long time. Therefore, we sprinkled the real world with all these little tags to make objects more easy to identify for software. So you carry a credit card. It's got the magstripe. When you swipe it, you go from physical object to voltages to bits to looking up who you are in a database at a bank. Similarly, your car has a fast track thing. It's a radio frequency identifier. You drive through the toll booth. It turns into bits. They can look you up in a database and charge you. Your cat or dog has a microchip so that the vet can scan them, get an ID, and again, they look you up, they look the pet up in a database, can bring them back home. In my factory, the tool of choice for identifying objects and making them trackable is the barcode. Now, I'm supposed to do that thing here where I say this is a zebra and this is a laser. And the sort of trick is that I have to type while I'm doing that. That's kind of difficult.
You want me to do something?
No, I'm good. So just imagine the barcode scanner is doing this thing where you see the laser lines. And if you slow down time, you just see the one point of the laser traveling. And wherever it's doing the white, you're doing your data acquisition, and it's recording white pixels. And then, of course, at some point, we keep going, and we hit the black. And then we're recording black pixels. And then it just keeps magically going as you scan the rest of the barcode, right? And that's step 1 of reading a barcode, data acquisition. Now, we enter that and we see we have our data, and it's kind of cool, but there is some noise in there. There's like the 0 here. That's probably a weird artifact of reading the data that's not really there. So we have to do some image processing. So most people, when they hear image processing, they're like OpenCV. I hear image processing, I say list comprehensions. Because that's basically what image processing is. You write these functions called a kernel that take in a small number of pixels, maybe like 3 in our case. They implement a very simple algorithm. In our case, we want to check if the outer 2 pixels of the set of 3 are identical and the inner one is not, and if so, smooth it out. So we've written the kernel function. Now we need those windows that the kernel is actually running on. We want like a sliding window across our data. The way we do that is that we want, obviously, again, 3 pixels in our window because that's what our kernel expects. And we get that out of 3 distinct copies of our data that are just offset by exactly 1 pixel each time. And that way we get this sliding window, and it looks like it looks like that. What did I do wrong? Anyone see it? Oh, here, in. There we go. So this is the first, second, and third pixel in the first window. The second window has the second, third, and fourth pixel, and so on. So we apply our kernel to each one of those windows. So we shrunk them down. We already applied the smoothing, and now we just want to make it look nice again, put it back together into a string, and call it smooth data because that's our smoothed or blurred data. Now this is clean data, but it's not useful data. What we actually care about is how many like pixels are next to each other, how many black pixels are adjacent to each other, how many white ones. So what we want to do is group them. And of course this is Python, and Python has batteries included, as you all know. And one of those batteries is the itertools library, and it has this function called group by that basically does exactly what it says. So let's check out what's inside those iterators real quick. Oh yeah, those are our groups of pixels, exactly what we were after. We don't actually care about the pixels themselves. We care about how many of them there are. We don't care about the label. The barcode might have been inverted anyway. And we want to trim off the first and the last one because that's just the surrounding white space. Voila, we've got our groups of ones and zeros. Now, I came prepared. I looked at the Wikipedia page for barcode before I came here. So I know that the start of the barcode type we're looking for a bar of width 2 elements and then a white space of width 1 element. So if you are eagle-eyed and look at our data here, you realize we probably recorded 4 pixels per barcode element. So what we're just going to do is we divide that by 4.0, get this. There's some like weird artifacts in there. That's just the real world saying hello. So we round that away. And we have that thing that looks pretty nice. So I think these are our bars. I'm going to turn it into a string again real quick. And when I practice this, I always stumble over this one. That also has to be a string. Boom. Now, the 2, 1, 1 you see, if you look at the barcode, this is a bar of width 2, then space 1, bar of 1, space of 2, bar of 1. That's exactly what our data is. Also, if you go to the Wikipedia page for this thing, code 122, and look at the table of encodings, you realize the last column looks exactly like the stuff we just created. So we really just want chunks of 6 that we can look up in this table, and we should be able to figure out what our barcode actually means. So again, it's Python, batteries included, lots of really straightforward syntax in the standard library. To do an important little task like this chunking thing. So we've got our chunks of 6 out of this intuitively named function, and then we put it back together into little strings. So now we can look those up. Let's see what those are. This one is the start of a code. Yeah, I can see that. It's at the beginning. Let's see what this one is. That's the end. I like it. So we'll skip this one. That's a checksum. I can tell you that. Let's see what the actual payload is. It's an uppercase P. We're at a Python conference. You can see where this is going. This is an H. And this one, sorry, copy that. And oh, that's a P again. Our barcode reads PHP. All right, why did I do that? That's nonsense, right? No one reads barcodes like that. The reason I wanted to really keep this in here is that, well, one, I like sort of like goofing off with the standard library and doing silly things like list zip iterator, do that. The second one is that I like to sort of explore new topics from first principles. And because Python is a language that's pretty intuitive, and once you learn the basics, you can do a lot of pretty gnarly things with it, I always find that it's useful as a language to just sort my thoughts. So in this case, it was pretty easy to see that we do data acquisition, we do some image processing on the noisy input, we turn the bits into actual data that we can look up in a table, and then out of the data we get the information by decoding it using an encoding table. So that's what's going on, and that's the principle of reading barcodes. Now, a brief section of theory. There's a couple of things that I just wanted to cover before we dive into Python, and one of them is the term symbology. What's a symbology? A symbology is to barcodes just like what a language is to human speech. A symbology defines how geometric primitives like lines, circles, or dots in a matrix appear in a barcode and how they can be arranged in space. Very much like a human language defines how tones can be chained together to form words and sentences and so on. Also included in symbologies are the kind of symbol tables, like the one we just looked at, where we went from pixels to bits, and then what's called the encoding, how you go from bits to information. And finally, some of those symbologies, some of those specification documents contain information about checksums, error correction, and the like. There's a distinct concept called the code, which is concerned about what's in the information. Does it look like a postcode? Is it a part number? Is it a product code? And we're not really talking about that in today's talk as much. This is PHP from the previous example. just as a reminder, what we did, we looked at individual characters, and we found that each character is encoded by 11 slots, which contain 3 bars and 3 gaps per character, and the maximum bar size is 4 slots. A couple of things that you immediately can tell about this symbology. It starts with a black line and it ends with a white one, so you rely on the next character following immediately thereafter to know how big the last white gap was. And that's why it's called a continuous symbology. You can also keep chaining those as long as you want, so it's a variable length. You aren't limited into how much data you can put into it. If you do the math, you figure out you can do 106 different characters with this symbology, but they advertise it as code 128 and claim that they can do full ASCII, so they had some magic with 3 encoding tables. They can switch back and forth with them. It's pretty crazy stuff, but that's how we figured out P, H, P, the whole payload, the checksum, surrounded by stop codes, and then white space around it so that the barcode scanner knows where the barcode starts and ends. Here's another one, just a randomly picked one. This is called code 39. 39 for 2 reasons. One is that it can encode 39 characters. The second one is that based on the fact that you have 12 slots per character, each one of those containing 5 black bars and 4 gaps that only can be of 2 distinct widths, there's always 3 wide ones, either 3, the sum of the wide black bars and the wide black white gaps is always 3. So in this case, we have the black white one, the other black white one, and towards the end, a white gap. And you know, what's special about this? Nothing is really special about it. Some other person invented it and published it, and it caught traction. One thing that's special about this one is that you can have gaps between individual characters. Cool. And this is what PHP looks like here. They actually sort of forgot to define a checksum, and they were like, oh, start code, end code, man, let's just throw in an asterisk character, whatever. This is like a third one. I'm just showing these to you to give you some ideas of what concepts you might encounter if you ever read up into symbologies. This is called interleave 2 of 5, because this is actually 4 digits. It's a numbers-only symbology. This is today's date, August 18th. And the 0 is encoded in the black bits of the first half. Then the 8 is actually encoded in the gaps between the bars that encode the 0. And then you keep going pairwise, where the second pair then encodes in the black bits, it encodes the 1, and the white gaps in between encode the other 8. And that's how that works. Some other industries, they have problems with actually printing and sensing widths of bars. In postal sorting centers, the letters fly by as they print those lines on there and also as they read them. So what they do is they don't rely on widths at all. They have a clock track at the bottom and the presence or absence of a bar on top in the second, so the second floor of the barcode defines what the barcode is. And this is actually the zip code of the location we're currently at. Using the encoding that the USPS used until 2009, and now they use a different one. This exists in every country. The Germans invented the same kind of concept at the same time. Like the orange bits at the bottom there are the barcode. Someone stuck on like a little thing so that humans can actually decode it. They didn't need the clock track for some reason. It just got invented in parallel. Turns out the encoding is literally the inverse and read in reverse of what the old PostNet barcode in the US did. UK, they have letters in their postcode, so they need an entirely different encoding. Australians copied the one from the UK. Canadians could have done that, but didn't. They just came up with their own thing. Dutch people, same thing. There's like about 20 different postal barcode symbologies in the world, and nobody knows why. Also, lawyers can be innovators too. This was the thing that appeared, this was like one of the unicorns of the first .com bust. They had to put the bars at an angle to work around existing patents. And then they had to scramble the encoding so that if you used their symbology, they would slam you with a Digital Millennium Copyright Act infraction. How about that? Lawyers contributing to technical innovation. Of course, then you start writing bacon, and you need a certain height of barcode so that when you swipe your laser across, you actually catch the whole thing. You write bacon and eggs, you have to write it a little taller. You write bacon eggs with toast. You're like, man, this is taking up my entire slide. You want to encode the entire recipe, entire menu item, and you stack your barcodes on top of each other. This was a major innovation at some point in the 80s. So you scan it like this, and at the end, you know, this is before breakfast, blah, blah, blah. Exactly 49 characters. Someone else was like, hey, I can do 77. And then someone else came along and was like, you know what, this whole laser business, that's so outdated. Let's come up with this one. You know, you can write pretty much as much text as you want by just stacking these thin lines on top of each other. That's what's on boarding passes now, and it's considered a high-capacity symbology. And once you do that, you might as well just put like pixels on a square. You call it data matrix. and open source it, which makes it super popular in the world out there. This is PyBay. Same concept as a linear barcode. You have the surroundings, like the guards. You have content in red, and then lots of error correction in yellow, because this kind of barcode is obviously more prone to errors when you read it. And that's that. You can stack it even more until you have like the whole sin of Python in there. You can put it into your cornfield. If you're Japanese, you're like, actually, we like to be a little bit more professional. We put 3 fiducials at the corner, so it's easier to locate it. Also, you can encode kanji characters with it, which is kind of convenient if you're in Japan. And then the Chinese are like, look at us, we can grow a forest. And then, lots of other people come up with lots more of those symbologies. I'm not even going to talk about them. I just want to let you know that they exist. Someone might ask, hey, what about these and the ones in the supermarket? Well, that's called UPC. There was a competition in '74. IBM almost won, except they got like the top bit of their proposal chopped off, and the bottom one is the one we've seen in the supermarket since then. This is the list of symbologies I just talked about. There's more. Are they actually getting used? Yes. This package appeared in our apartment building 2 weeks ago. It's got 5 different ones on there. Some others have special applications in specific industries. Like if you ever need a blood transfusion, the bag will have, I believe, a Codebar barcode on it. Libraries have the one that's been stuck in that industry, and that's how these get used. How do you pick a symbology? Well, hopefully you work in an application where the symbology is defined by standards. If not, keep listening to me. Let's talk about reader technology real quick, because that's basically how the symbology evolved. Like, how do you read barcodes? Well, the first barcodes were these crazy things mounted to rail cars in the 70s in the US. Looks like this on close-up. They basically put a 500-watt lamp next to the railroad track. We're trying to gather what the idea of the rail car is from the reflection. 90% of cars actually had that in the US, but it never actually worked, so they gave up on it. Then the laser got invented, and we actually had these laser pens where you would run your barcode reader across the barcode like that. Required quite a bit of skill, actually. You had to get the speed right, you had to start in the right spot, end in the right spot, not wave around, all that. So someone was like, hey, you know what? I'm going to put that laser into a little box, put a mirror there, and when I move the mirror really fast, we get that system where you see the lines like I demonstrated earlier with my hand. And when you go to the supermarket and they have like lots of lines, and it looks like Ocean's 11, you know, the thing where they have to climb through, that's just one laser or maybe 2 with lots of mirrors going crazy. And then finally, so this is still lasers. We're still scanning linear symbologies. What really made those 2-dimensional symbologies possible is barcode readers that use cameras like the one that's in the phone, and then do image processing on this. And the way these actually work, I brought one. This is just a barcode reader, and I'm going to tab out and just go to a text editor real quick. And I brought a barcode. Just going to read it. That's how it works. There's one on our conference badges, QR code. Oh wow, that's me. That's how these things work. And how do you tell them apart? Well, if you hold it and it kind of shakes, there's a mirror in it. It's a laser-based one. If you hold it, it doesn't shake. It's all solid state. It's the imaging-based one. And usually the imaging-based ones also have the green light, just because, well, actually, why? These are 3 barcodes. And this is why it matters that you know how your barcodes get into your software or come out. The first one, easy peasy. That's how barcodes look. The second one, most scanners can read that. The third one, laser-based scanners can read it. Image-based scanners grayscale everything, and they see that. So it makes sense to know the entire stack, try to be a full stack engineer when you work with barcodes, and be aware of little technical limitations like that. Same for printing. If you print something like these codes that were printed on a machine where the, kind of like the mail printing machines where the paper flies past as it gets printed, you better expect crooked lines, because this is really hard to do. Like you're printing on a piece of paper that's flying past you. If you're in other industries, barcodes get hammered into the workpiece or etched into it. And those methods obviously come with their own repercussions. And then this is just mind-blowing. I found out about this while preparing this talk. Salmon that comes out of hatcheries has barcodes in a bone in their head that they get there by cycling the temperature while they incubate the salmon. And when you cut open the salmon and cut through that bone, you get the kind of barcode pattern that you've got in there, and then you know what hatchery it came from. Look up otolith marking. It's magical and crazy. Now, we know all about barcodes. What do we do with it? Well, we want to use Python with it. What do you actually do with Python when you deal with barcodes? Well, you could do 2 things, right? You could make the barcode, or you could consume the barcode, or both. Let's start with making it, because that's a bit easier, and then let's talk about reading barcodes with Python. Now, generating barcodes, we basically go to PyPI, you look for a package that has barcode in its name, you do pip install Python barcode, you write 3 lines of code, and you get an image out. That's basically how it works. Now, this one, you give it the symbology, code 39. I wanted to write PyBay. Of course, I know that code 39 only supports uppercase and numbers, so I took care of that. It kind of printed out like in the little text at the bottom, printed out the checksum. There's some less obviously named packages, like ubiquitous. Does the same thing. Then there's popcode, which, that throws an error. It says pillow isn't supported. So all the ones I showed you so far output SVG files. That's easy, it's just text. When you want PNGs or JPEGs, a lot of libraries want pillow, which is a compiled dependency like the Python image library. It's a bit annoying, like you can install it on most machines to get the barcode. But on Windows, for example, it can be a bit of a struggle to get it up and running. So there are yet others like this example, PDF 417 Gen, which actually uses a pure Python implementation of the PNG standard. And this is the sort of stuff you might want to worry about when you generate barcodes with Python. I did, so I made a table. So this is my review of all the barcode generating libraries that I could find in PyPI, compared by a bunch of things like latest release date, what symbology they support, and how the output works. And you can look at that in your own time. My recommendations are, if you have only simple and common symbologies and you just need a quick, easy to install library, Python barcode is your pick. If you need advanced features, like crazy symbologies that no one else is using, lots of configuration, like checksum in this weird way, and this like 80s version of the standard, not the current one, use this thing called tree poem. That name comes from barcode, tree poem. And it wraps around a PostScript thing that actually generates all those things. So you have to install PostScript to make it work, and then it gives you the benefit of using that tool. If you have specific requirements for certain types of barcodes, I listed a couple of libraries that are my preferred picks for those symbologies based on mostly convenience, being easy to install and the like. Reading barcodes with Python. What do we do about that? Well, we don't do it. That's really, you want to use custom hardware for reading barcodes whenever you can. If you have custom hardware, they optimize the lens so that they optimize for having the full field of view, but it can be distorted because the barcode reader doesn't care. You can optimize the image sensor. The colors don't have to be correct. They just care about contrast. You can optimize the processor in there to be good for image processing as opposed to a general purpose CPU. So you should really, when you can, buy one of those things. The price ranges from probably like $30 for that thing in the corner in the stand, the gun-shaped one, like the one that I have here, to probably a couple of 10,000 for the airport scanner style thing. If you are stuck with Python for decoding your barcode, maybe because you get the files sent as image files, pick your poison. You've got 2 options here. None of them is actually a Python option in the pure sense of the word. CBAR is a library that's written in C and C++. The last time an update has been pushed to that thing is 2009. For some reason, it's still the preferred pick of Stack Overflow answer givers when people ask, how do I use Python with barcodes? It implements a limited set of symbologies. There's actually a couple more in the code that aren't in the docs, so I'm not really sure what's up with that. But that's the C++ version. Zebra crossing, like I'm a foreigner, it took me 5 years to figure out that CXing means zebra crossing. So zebra crossing is a Java library for reading barcodes. There used to be a C++ rewrite, fork, port, whatever it is, but that's unmaintained. The Java one, however, is actively maintained, and it actually supports several more symbologies than CBAR. So it is probably the better option if you can put Java on your system, which some people can and others can't. I listed for completeness libdata-matrix, which is a data matrix only library that you can look up if that's relevant to you. How do you use CBAR? Well, you go to PyPI, you search for CBAR, you find a package called CBAR, and you stay as far away from it as you can. Because that's last updated 2009, just like the main library. It's Python 2 only, and who wants that? Of the other ones which I reviewed, CBAR Lite is my recommendation if you're looking for just a Python 2, Python 3 system that you can use on Linux-based systems. If you care about an easy install on Windows, maybe go for PyCBAR, which is maintained by the Natural History Museum in London, which I think is cool. And they make it an explicit point to advertise the Windows support. Zebra crossing, on the other hand, is a little bit easier. There's only 2 results. You want to in this case, use the one with the obvious name. What that actually does is it just downloads the jar files of the Java library zebra crossing during the setup.py. And then when you run it, it just runs subprocess popen, runs Java in a shell in the background, and grabs the result and outputs it to you. So it's a nice little convenience wrapper, not actually doing too much. Stay away from the zebra crossing light one, because that's basically an outdated Python library that wraps an outdated fork of another library, so no one needs that. The other, here's an example. How does that work? It's actually pretty easy. This is a package, by the way, that contains a barcode scanner. How meta is that? So I took a picture of it, passed it to zebra crossing. You get the tracking number, of course. You get information about what the symbology is and where the text is in the picture. There are some other options. There are commercial SDKs, because there's huge demand for putting barcode scanners into cell phones, basically like into smartphones. So there's a whole range of SDKs. This slide is not an endorsement of any of them. I haven't actually used any of them. I could find two that mention Python support, either through a PyPI package or because the vendor will give you a Python shim to use the library. And then the others are written in C and .NET and Java, and there are the usual ways of bridging from Python to those using cfflib or calling with subprocess or using Jython if it's a Java library, something like that. Quick shout out to this thing called OpenMV, because that keeps coming up when you Google barcode in Python. It's a little camera like this. It's meant for hacking on image processing algorithms. They do mention that they support barcodes. It's actually ZBar that's running behind the scenes when you do that. And I have it here probably tomorrow at the MakerFest. I'm happy to show it off. Finally, if you search barcode on PyPI and the first result is actually barcode, this is for NGS barcodes. What kind of symbology is that? That's next generation sequencing. This is a bioinformatics library. It won't help you at all if you want to do anything with barcode. So just FYI, saved you some time right here. Finally, I've got 4 minutes left, barcodes in the real world. So now you've got your Python code, you can read and make them and whatever. What could go wrong? I'll tell you. First of all, you can think of barcodes like real-world browser cookies. Like White House Black Market sends my wife that thing. They print the barcode. It goes to her. She's meant to bring it back to the store. They scan it again. It's literally what a cookie does in your browser, right? Everything that can go wrong with cookies in your browser can go wrong with barcodes here. Like, for example, someone might actually analyze what's in there, realize all the numbers add up to 60. Maybe that's the scheme by which they validate them. I should try. Or maybe someone just randomly prints junk ones with bad characters that break your point of sale system. Like, that's the kind of stuff that can happen. You have to be prepared for it. By the way, if you want to take a quick picture, those are single use, still valid, and not used yet. If you use barcodes as carrier for information like URLs, don't just go to your designer, say, put a barcode on there and then print it on the ketchup bottle, because it might be a link to a porn website that your designer put on there. This actually happened to Heinz. This is the broader thing to be aware of here is that the text next to the barcode doesn't have to be the same as what's in the barcode. It can be different. And people actually exploit that when they go into stores and put different barcodes onto products, keep the number the same. It looks all right to the cashier, but they actually pay a different price than they should be paying. Barcodes as passwords, oh my God, United. They treat your frequent flyer number like a password. You can call them up, you use your frequent flyer number, they know who you are. They never print it. It's always like a social security number, like with the asterisk is there. And then in the barcode, which you can scan, it's right there. Like, barcodes aren't encryption, it's just writing the same information in a different way. There's literally apps in every app store to decode your barcode and get all that stuff out there. So don't do that. Also, don't do that thing where you're on Instagram and you're like, oh, I'm going to Thailand and here's my boarding pass, but I'm hiding all the important information, because it's actually there. So while you're flying to Thailand, someone is logging into the airline website and canceling your return flight, and you'll be in Thailand forever. There's actually a great Chaos Computer Congress talk about all the various combinations of security holes in the airline industry, which is quite fascinating, and it's in the appendix slides that I'm not showing here, but they're on my website. Now finally, read the manual. This is like 3 parts of reading the manual. First of all, your barcode scanner in its purest state is like an open Windows computer without a firewall. So I'm going to scan like that White House Black Market code. Did you hear the beep? Yep. Yeah. So now they gave me this manual with the barcode scanner, which is full of barcodes. One of them says low tone, low volume. Did you hear the beep? No, because I reconfigured the barcode scanner to be very quiet when it's successful. Now I'm going to make it loud again. And I'm going to make it quiet again. The unfortunate thing is, these aren't the only configuration codes in there. There are ones for enabling symbologies and disabling them. Then there's the one for adding prefixes in front of every barcode scanned. And then there's the one that adds a suffix. You can do a lot of damage that way. So better lock down your barcode reader, disable reconfiguration with barcode scans or whatever else is necessary to make that thing a little more rugged, just like you would do with a web server where you don't keep port 22 open without a password. Similarly, read the manual on your symbology. Some symbologies, like the interleaf 205 I showed to you earlier, is very prone to partial scans that look like they're valid scans. So the recommendation on that specific one is use it for fixed length data so you know when something is missing. Otherwise, you might be scanning like some price tag. Maybe you were kind of silly and put the actual price of a product into a barcode. It's meant to cost like 1,001,000, but because they spilled coffee on the first part, they only pay 1,000. You don't want that. And finally, the last one is a good one. Barcode scanners read other characters. So I've got a quick demo here. This is just some fun thing where I did change the barcode. So I'm going to scan that off my screen. This is my barcode scanner. Wait, what? I'm scanning, I'm scanning the barcode and it's rotating what's on my screen. Well, barcodes can contain special characters. Here's a quick story. This is like 1 more minute, and I'm allowed to do 1 more minute. Okay. I had a product code that was a bag of electronics that arrived in a factory. I scanned the code. It was a GS1 data matrix code. GS1 data matrix specifies the function 1 character as a separator. Code 128, which was part of how it was encoded, specifies the function 1 that maps to 64 hex. 64 hex on my barcode reader that I used to scan it maps to the F8 key. And I had the Chrome developer tools open where F8 means stop script execution. It took me 3 days to figure out why my JavaScript isn't running when I'm scanning barcodes. Quick summary, outsource the decoding if you can. Use the symbology that's right for your data. Configure your reader hardware correctly. Validate the input as if it was user input, because it is. And if your software hands out barcodes, treat them like browser cookies. Never include secrets in there. This is my last slide. We don't have time for questions, but you can reach me on Twitter or by email. Also, if you're on YouTube, that's the same way. You can reach me that way. Thank you.
All right. Thank you very much. That was really great.